Bangalore at the Great Indian Developer Summit. Eric, can you tell us in a bit about yourself and your role at ThoughtWorks?
ThoughtWorks organizationally is a very flat company. There's not much hierarchy, so there's not much grading going on. But what I would call myself is probably one of the senior technical people in ThoughtWorks. As such, I often help with at the beginning of our delivery projects to set the technical vision, to start thinking about an architecture and get the team on the way, or on the projects where we do high-value consulting, where there's a small team that addresses a specific business situation from a technical angle and provides advice to our customers.
Right. Eric, software visualization is a concept that is close to your heart, and it often brings to mind complex modeling tools. What is the strategy for software visualization that you're putting forward?
I think there's definitely some truth in the old saying that a picture says more than 1,000 words. And at the same time, I think some of the approaches that we're seeing today have gotten it the wrong way around. So rather than trying to struggle with very complex tools to create these useful pictures, what I generally advocate is working the other way around. So what we do is we would use a textual representation that we generally use in development and create the diagrams from it. So we can have it both. We can have very efficient tools to manipulate text in the way that we're used to, and at the same time have the diagrams that we all find so useful.
Okay, right. And what, according to you, are the most important metrics that any software project should track?
The most important metric really is progress. So what they should absolutely track is how much they have done of the overall scope. How you track that is a very different story. As many of you might know, ThoughtWorks is a company that does a lot of agile work, and some of the fundamental principles that we use are story cards, which are very small units of work that are small yet meaningful to the business. So the most important metric to track is how many of those story cards you have, how many you have finished, and how many are there out.
Perfect. Eric, you propagate the idea that simplifying the software rather than simplifying the complexity of the problem better attacks complexity in software processes and projects. Can you elucidate on this in a bit more detail?
Yes, there's two answers to that question.
Okay.
One goes back a long time to Fred Brooks and his essay on the No Silver Bullet, where he identifies two forms of complexity in software projects. One is the essential complexity, that is the complexity of the problem that just exists. The other one is what he calls accidental complexity. That is complexity that, as the name alludes to, is accidental. It has nothing to do with the problem, but it is there for some other reason. And oftentimes this can be development tools, these can be unsuitable frameworks or ill-thought-out ideas, but nothing to do with the actual problem. As you'll see a theme, I'm very much about delivering business value. I see IT very much as a service, not as a self-serving science. So what I want is to deliver business value, and it is not up to me as a software developer to decide how complex the problem is that I'm solving. It is the problem that the business has. So that's what we need to focus on.
Sure.
The second part of that answer is that if you look at what Eric Evans says about domain-driven design, that he also says we need to tackle the complexity at the heart of software. And he very much talks about complexity, again, in terms of the software development domain, in the domain of the problem that we're solving, rather than struggling with tools or with unwieldy frameworks.
That sounds great. Eric, can you talk to our viewers in a bit about some of the common myths about developer productivity and why productivity improvements often require a trade-off with other desirable goals?
That actually relates very much back to the previous question. Oftentimes, I find that parts of the IT industry are very self-serving. People are coming up with products, with frameworks, with solutions that are sometimes in certain cases almost pieces of art. They're very intricate, they're very flexible, they allow you to do a lot of things. But on the other hand, it is these things that take a long time to develop. And sometimes in projects, people will start using all sorts of tools that might look interesting, but in the end, if you look under the surface, actually don't deliver any productivity. So it is this false assumption that if something looks shiny or something looks refined, that it automatically makes it go faster. What I really believe in is reducing things to simplicity, to have a very, very simple approach to things.
Sure. There are always good things to say about agile methodologies, but more so often project teams fail when it comes to proper implementation. What, according to you, Eric, are the top reasons why agile teams fail to deliver?
Yeah, I could talk about this for hours. I'm actually doing an hour-long talk on that topic, and there's a good few reasons in there. But if you ask me to really drill it down to one, it is not being agile. I mean, what you see is that people are looking at agile, they probably have read a book about it, and they're trying to implement agile exactly as written somewhere else. One of the core principles that we see about agile is that you need to adapt. There is no right agile process. It is being agile about how you approach a problem and taking what other people have done as guidelines that guide you. But it is really vitally important to focus on the principles and the outcomes and not in following rules.
That's great. Well, Eric, is there some sort of an Eric's best practice guide to choosing technologies for a project, or alternatively working around chosen technologies to ensure project success?
To be honest, if there was one, I'd be happy to write it down.
Okay.
I have never really been able to formalize it. Again, as with what I answered in response to the last question, is just common sense and see what you're doing. I mean, try to find out what the determinants are of your project. Try to figure out in a language that doesn't involve specific technologies what it is that you want to achieve, and then pick the technologies. So in other words, to complement what my colleague Jim Weber is talking about, don't pick a service bus and see what you can do with it. Try to figure out what you want to integrate and then make a decision on whether a service bus is the right thing.
Fantastic. Why should developers use continuous integration in the projects, and what problems can it solve, and what are the tools available to do this, Eric?
One thing that I'm seeing more and more often, and one of my colleagues has called it the last mile problem, is that we have done so much in recent years to make it faster and easier for developers to write code, easier to turn ideas into working code. What we haven't concentrated on so much is making that code work on a production machine. It's the typical, oh, it worked on my developer workstation. So what we need to figure out is how we can have ever-growing teams develop quality software that actually works in a production environment. And continuous integration describes that process, that code doesn't sit on developer workstations forever, that it gets checked into central source repositories very, very quickly, that we have unit tests and acceptance tests that run over it right away to find bugs right away, and then have very scripted and automated deployments that allow us to deliver that software and give it, or put it into a position where it makes sense, namely delivering value to the business. And a piece of source code that lives on a developer workstation, unfortunately, gives no value to the business. It is only working software, and integrating that continuously gives the business that value so much earlier and much more reliably.
That's interesting. Eric, during the course of building the new Guardian.co.uk website, which you were very deeply involved with, can you share with our viewers some of the approaches used for measuring performance and scalability tuning?
Yes, the Guardian website. That was actually a fairly big website. It is the largest newspaper website in Europe. Interestingly enough, a lot of people have said, oh, but it's not that big if you look at the hits it actually gets when you look at normal traffic analysis these days. It is still sizable, I would say. The challenging aspect here that we were required to work on was actually dealing with those days where there's a lot of traffic to news websites. I mean, it is a newspaper website, and the idea is people go there when something goes wrong. So on days like 9/11 or the day of the London tube bombings, that is when those websites see their spikes in traffic, and that is what we're building for. The performance testing, very much in line with what I explained about continuous integration, was done in a continuous fashion. So almost every time when a developer would check in a modification to the source code, those would be bundled up, and then a performance test would be run generally overnight. And coming back in the morning, we could easily see what has changed the performance characteristics of our application. So you got a very short feedback cycle for developers. You know immediately what you've done yesterday. If you come back in the morning and you find out that has slowed things down, you don't have to search for a long time. It's a very different approach from leaving performance tests to the last, where at the end you have an application that doesn't perform and you have no idea where to start. So this is to keep an eye on these things continuously. We did also at the end though, after we made sure that performance was at an acceptable level, we did do extensive profiling to iron out some of the other performance bottlenecks.
Alright. Eric, can you wrap by sharing with our viewers by engaging in a bit of crystal ball gazing of where you see software engineering headed, and what you see as the next step in the evolution of agile methodologies?
I'll start with the second part of the question. The evolution of agile methodologies, I think, will continue forever. I think we have now understood a couple of principles that are really valuable, and we've seen being employed successfully at so many occasions that I don't think these will go away. One of it, what I described earlier on, is that focus on delivering business value, on the focus on simplicity, on delivering actually what is needed rather than trying to second guess. When it comes to all sorts of other practices, we simply don't know yet. There's going to be a lot of change. I would personally predict that we'll see more people doing pair programming, more people realizing the beneficial effect of having multiple people working on the same problem and sharing knowledge, having what we call collective code ownership across a wide variety of people in a team. When it comes to software engineering in general, I think we'll continue to see a lot of what we've seen in the past. So I guess we'll see a lot more language wars. We have seen people when Java came out, the C++ developers were unhappy, or vice versa. We're seeing this with Ruby on Rails now, but the Ruby on Rails people are now talking about Erlang. So I think ultimately many of us are very binary, so we always want to compare with what we have with something new, and I think we'll keep doing that. But I think on the upside is every technology that came out, while maybe the language or the platform itself stopped existing or stopped being very popular, introduced new ideas. So we saw ideas like managed memory, garbage collection. Then we saw something like simplicity and convention over configuration with Rails. With Erlang, we'll see something that deals much more about parallelism and how we can deal with parallel systems to exploit the fact that nowadays CPUs get more cores but not more gigahertz. So I think what we'll have is we'll have an industry that will gradually adapt to the changes surrounding it, but we'll come up with ever more programming languages that will come and go.
Cool. Eric, it was great and it was an interesting chat that we had around with you. I'm sure our viewers are also going to enjoy this. Thanks so much for your time.
Thank you.